Okay, so we got interrupted there because of the length of the video. The software won't let me make it much longer. So I'm going to pick up where I left off. I was just putting a scale on here. So just to finish the scale, there's -8, and we can go out from there. But we're going to draw these 2 points. 12, 0 is here. 0, -4 is here. And then we're going to put a line through them. And we have to decide, is it going to be a dashed line or a solid line? And that is based on that sign right here, this less than or greater than and equal to or not equal to. So you have to look at this. In this case, it's a less than, and it's not equal to. There's no bar underneath. So that means it's going to be a dashed line. So we're going to draw a dashed line through here. All right, and we're going to try as best we can to make it look like a line. And then we're going to test to see 0, 0 is an easy one to test. So we're going to test that point, and if it's plugged into our equation, it becomes 0 minus 3 times 0 is less than 12. And so the statement is 0 is less than 12 because 0 minus 0 is 12, or 0. So 0 minus 0 gives me 0. That's less than 12. I say that's correct. And so that means that 0, 0 is a solution, which means all of these, everything up here, is a solution. So there's our first graph. Then we're going to draw our second graph. Our second graph is in red, and the 2 points we have to plot are 3, 0, which is right here, and 0 and 2, which is right here. This time, the sign is greater than or equal to. So because it's equal to, it's a solid line. So I'm going to try to draw a solid line. Let's just try that one more time to make it a little better. There we go. A line down that way, and we're going to continue our line up here. And then we're going to shade it. And in order to shade it, we have to test 0, 0 again to see how it works. If it gives me a statement when I plug it in that it's true, then I shade where 0, 0 is. If it's not true, then I shade away from 0, 0. So it's 2x plus 3y is greater than or equal to 6. So we go 2 times 0 plus 3 times 0 is greater than or equal to 6. And so this whole side just becomes 0 is greater than or equal to 6. And that's not true. Okay, so that means that 0, 0, that point is not a solution. And if that's the case, then I'm going to shade away from it. So I'm going to shade everything up here, all right? And then the last one, which we did in blue, is just a line that's horizontal. It's just y equals 2. So here's y equals 2. So we're just going to have a horizontal line come out this way. And we're going to go back this way as well. And it's less than or equal to, so that makes it a solid line. And it's less than, so we're going to shade down below it. So it's going to be all of this area in here. All right, and if we had shaded a little more carefully, I'm going to shade in, this is the area right in here where everything is shaded, all 3 colors. These 3 colors are all right in this little box. And just to outline it for you, it's this line out to that line, down here to that line, and then back up. That right there is our solution region, where if we pick a point that's in this region, it's true for all 3 of these. Okay, so let's take 8, 0 for example, just to show you. So if I go 8 is less than 12, okay, 8 minus 3 times 0, but that gives me 0. So that is true. If we go 2 times 8 plus 3 times 0, that is greater than or equal to 6. That means that we're saying that 16 is greater than or equal to 6. We're saying, yep, that's true. 8 is less than 12 is true. And then 8, 0, there's no x here, so we don't have a place to put the 8, but the 0 goes in for y, and we say 0 is less than or equal to 2. We say that's true. So that point is true for all 3 of them. Does that make, hopefully that makes sense. We're trying to say that anything in here is right. But if you choose something out here, it will be true for the black and red equation, so 1 and 2, but not for the blue one. Down here, it's true for the blue and the black ones, but not for the red one. Over here, it's red and blue, but not black. Down here, it's just blue. So you can kind of see there's different regions that the points solve 1 or 2 of the equations, but not all 3. Just this does all 3. And that is what is called our feasible region, so, or our solution region. So that's how you draw a system of inequalities. And what we're going to do with that next is we're going to then try to make it into an optimization problem. So we're going to try to take this concept and make it something that we do in a contextual problem. So something that is actually a real life situation. So I'll just show you, we're going to do this in another video, but here's a question where we're going to take what we know about inequalities and we're going to try to make it apply to, in this case, sailing. All right. And then in another case, the second case, we're going to do something with oil and gas. So we'll show you how to use this in contextualized problems, but for right now, all you have to understand is how to draw a 2 or 3 set equation system.